Hey, welcome back to your favorite technical mathematics class. We're going to look at solving a simple equation today. So, just a few vocabulary reminders. When we refer to an algebraic expression, it's just a collection of variables and constants joined by arithmetic operations, like 2x plus 3 would be an algebraic expression. Whereas an equation, you got to have that equal sign, equals 11 or whatever. And then the solution you only have solutions for equations, right? There's some x value that makes this true. You find what x value that would be, which of course would be 4 in that case. The addition property of equality says, hey, if a equals b, if 2 equals 2, if I add something to both sides, like 3 to this side, then I got to add 3 to that side so that I still end up with an equivalent statement there. Same thing if you have the multiplication property of equality. If you have 2 equals 2, well, if I multiply this side by 3, then I got to multiply the other side by 3 to make sure that I keep it the same. Both sides of the equation equal. Alright, so verbal statements, so we can set these up into an equation. A number decreased by 7 equals 12. So here's the first one. A number, we'll call that x, decreased by 7 equals 12. And then we can just solve that. Add 7 to both sides so that that's gone. We got 19. Number 2. A number divided by 2 equals 7. And then we solve that one. Right now we're dividing, x divided by 2, so you do the opposite, multiply by 2 on both sides. So you have 2 over 2, which equals 1. You multiply this side by 2. If you multiply the left side by 2, I got to multiply the right side by 2, according to that multiplication property of equality. Number 3, 3 less than twice a number. If you remember, less than goes in a different order. If you have like 3 less than 7, that's 7 minus 3. All right, so 3 less than twice a number equals 1 more than the number. Get all of your x's on one side, so subtract x. 2x minus x is x. So x minus 3 equals 1. Let me take it up here. X minus 3 equals 1. Add 3 to both sides to take care of that. X equals 4. Alright, number 4. 16 less 3 times a number. So here's number 4. 16 less 3 times a number equals 2 added to 4 times the number. Equals 2 added to 4 times the number. Get all your x's on one side. So you get negative 16 equals 2, and 4x minus 3x is just a 1x. Get rid of your numbers now. Negative 18 is the x value. X equals negative 18. And I'm running out of room here. So we're going to be on to number 5. As soon as I get rid of these. Number 5. 5 less than 4 times a number. So number 5. 5 less than 4 times a number equals 1/5 the number. 1/5 of the number. I'm going to write that as, 1 times x is x, 5 times 1 is 5. Alright, so I got 4x minus 5 equals x over 5. Make sure you get it all on one side, so minus x over all your x's on one side. And then all your numbers on the other, so I'm going to add 5 to this side, add 5 to that side. So I got 4x minus 1/5 x, or x over 5, equals 5. Got to get a common denominator with these x's so I can add these fractions, right? So if I multiply 5 on that, I got to add, or multiply by 5 there. So I got 20x over 5. Of course, it's still 4x. We got minus the 1/5 x, x over 5. And remember, there's a 1 right there, right? So 20x minus 1x is 19x all over 5. 19x all over 5 equals 5. And then we multiply by 5 on both sides. Get rid of the 5 here. So 19x equals 25. And divide by 19 on both sides. So x equals 25 over 19. Alright, number 6. Number 6. Half a number equals twice the difference. So twice the difference of the number in 12. Twice the difference of a number in 12. Go ahead and distribute that. So we got 2x minus 24 equals x over 2. We take this up here. And I'm going to get all my x's on one side. So I'm going to subtract this 1/2 x over here. And then I'm going to take my numbers to the other side, so add 24. So I end up with 24 equaling 2x minus an x over 2. Remember, you got to get a common denominator here. So times 2 times 2. So we got 24 equals 4x over 2 minus a 1x over 2. Well, 4x minus 1x is 3x over 2. So we got 24 equals 3x. That's a 3x over 2. Times it by 2 both sides. Times it by 2. So we got 48 equals 3x. Divide by 3, divide by 3. And that gives you 16. So x ends up being 16 once you divide both sides by 3. Alright, let's just solve some more given equations. So number 1 here, x plus 9 equals 3. X plus 9 equals 3. Right now you're adding 9, so we do the opposite. Subtract 9 to get rid of that. X equals 3 minus 9, negative 6. Number 2, x over 7 equals 14. So times it by 7 this side, times it by the 7 that side. So we got 14 times 7, 98. If you want to write it out or punch it in, whatever. Number 3, get negative 2x equals 14. Divide by negative 2, divide by negative 2. X equals negative 7. Number 4, we've got 2x minus 3 equals 1 plus x. Get all your x's on one side, and then get all your numbers on the other. So 2x minus 1x is an x. 1 plus 3 is a 4. There's number 4. Number 5, 16 minus 3x. Here's number 5. 16 minus 3x equals 3 plus 4x. So get all your x's on one side, get all your numbers on the other. So we got 13 equals 7x, divide by 7 at the end. X equals 13 sevenths. Let's see, number 6 here. Number 6, I'm going to distribute the 3. So I got 6 minus 9x equals 2x minus 9. Get all your x's on one side, subtract 2x here, subtract 2x there, get rid of the numbers. So negative 9x minus 2x, negative 11x equals negative 15. Divide by negative 11, both sides. A negative over a negative is a positive. So negative over negative, negative 15 over negative 11 equals 15 elevenths. Oops, that's an 11. 15 elevenths. Number 7, similarly, go ahead and distribute that 4. Go ahead and distribute the 3. So we've got 8x plus 4 equals 3x minus 9 minus 7. You can combine those on the same side before you proceed. Get all your variables on one side, all your numbers on the other. So 5x equals negative 20. Divide by 5 both sides. You get negative 4 on that. And then number 8 and 9, looks like we ran out of room here. Oopsie daisy. Ugh. Not too pleased with my software sometimes. But this is what I got for now. Alright, so number 8, and then I'll do 9 at the end. So number 8, we got 2x plus 2. Go ahead and distribute that 2 on the other side equals 2x plus 2. Well, 2x plus 2, if that equals 2x plus 2, can you see how if you get all your variables on one side, that's gone. You're just left with 2 equals 2. Well, here's the algebraic form of infinitely many solutions. Does 2 always equal 2? Yes, it does. So infinitely many solutions. Meaning, if I was to go back to this original equation, it doesn't matter what I put in for x. You know, if I choose x to be 3, for instance, 2 times 3 is 6, 6 plus 2, 8. Same thing on this other side, 2 times 3 is 6, 6 plus 2, 8. 8 will always equal 8. It doesn't matter if it's 3's or 4's. Whatever the x value that I choose, it can be any x value because the equations are equal. 2x plus 2 will always equal 2x plus 2. So once you start solving and you get something like this, you get two numbers left. If they're truly equal, you're going to have infinitely many solutions. Whereas if they're not equal, like if you look at number 9 actually, once you start solving this, you're like, oh, does 1 equal 2? No, 1 does not equal 2. This will have no solution. It doesn't matter what you pick your x's to be in that case. You'll never have a solution to it. There's no x values that will make that true. Well, thanks for watching. We'll see you guys soon.